In this video, we will discuss how to solve for K when you multiply and divide reactions. So we've got a reaction here, and I have told you what the K is. It's 2.41 times 10 to the fourth. And so what I want to do is I want to write the equilibrium constant expression, and the expression has no numbers. That is just K is equal to products divided by reactants. Okay, and so that'll be PB plus 2 times H2 divided by H plus squared, because that has a coefficient of 2, and then PB solid is excluded. Okay, so for the reverse reaction, products and reactants are just flipped, and so that'll actually be just the reciprocal, 1 over K. So that'll be 1 over 2.41 times 10 to the fourth. Plug that into your calculator, and you should get 4.15 times 10 to the negative fifth. Okay. Or you could think of it as K to the minus 1 power, which is 2.41 times 10 to the fourth to the negative 1 power. Okay, you should get the same answer. In C, what we have here is the reaction is still going in the same order, but we've doubled all of our coefficients. And if you remember, coefficients affect our exponents. So what we really need to do is double our exponents. And so K is just K, but we've doubled the exponents. So it's K squared. Okay, so we'll get 2.41 times 10 to the fourth. And we'll square it, which a lot of people would say that this would be 2.41 times 10 to the eighth. And I'm like, okay, so you squared 10 to the fourth, but you also need to square 2.41, and so that changes it slightly, and then 2.41 squared is going to be about like 5.8 or something. So we get 5.81, that's 2.41 squared. 10 to the fourth squared would be times 10 to the eighth. In letter D, the reaction is still going in the same direction, but we've halved the reaction, so we need to half our exponents because our coefficients are dealing with the exponents for K expression. So we'll take 5.8, oh gosh, goodness, 2.41 times 10 to the fourth to the 1/2 power. Or some of you would just say square root of 2.41 times 10 to the fourth. Either is fine. When you do that, you should get 1.55 times 10 to the second. Okay, so the last one here before we do example problem number 2 would be the reaction is now going backwards. So we need to take the reciprocal, but the coefficients have been halved, and coefficients are our exponents. So what we get is 1 over 2.41 times 10 to the fourth to the 1/2 power, or what you could do is just K to the minus 1/2 power. And this is something you want to be really good at plugging into your calculator. Okay, so let's do this second one. Here we've got a following table, and we want a spontaneous reaction. Well, if we remember from previous notes, that is going to be E cell is equal to E cathode minus E anode. And we have negative 0.25 volts minus negative 2.37 volts. This is the only combination that will give me E cell as positive, and so I get 2.12 volts. The reason why that is important is that I know that this is my cathode and this is my anode, and so I see 2 electrons. I won't need to worry about getting those to cancel because they just will. But here's what I'm going to do is my cathode is nickel, but then my magnesium one is my anode, so magnesium reaction really goes backwards. Okay, my equilibrium constant expression, need to have this, is going to be, what is it? K is equal to magnesium plus 2 divided by nickel plus 2. Okay. The equilibrium constant for this reaction is 4.94 times 10 to the minus 72nd. What's it for the reverse reaction? That would be 1 over K, which equals 1 divided by 4.94 times 10 to the minus 72, which is 2.02 times 10 to the 71st. You could have also done K to the minus 1 power. That's how you get a reciprocal. We double the coefficients, which means we double the exponents. Well, K is always going to be to the first power, so we'll make it to the second power here. And we'll get 4.94 times 10 to the minus 72nd. We will square that, and we'll get 2.44 times 10 to the minus 143rd. We divide the coefficients of the forward reaction, so it's still just K, not 1 over K, but we divide them by 3, so it'll be K to the 1/3 power, which equals 4.94 times 10 to the negative 72nd to the 1/3 power, which is 1.70 times 10 to the minus 24th. Here we have the reverse reaction, so that's 1 over K, or K to the negative some power. We divide our coefficient by 4, and so what we get is 6.71 times 10 to the 17th power.